Here it is asked to find the radius of the largest interstitial atom that can be accommodated in an octahedral void in BCC iron without distorting the lattice. And also they have provided to assume a hard sphere model, and the radius of an iron atom is 0.124 nanometer. So here the schematic of reduced sphere BCC unit cell is shown, and also hard sphere unit cell is also shown. As we know, body-centered cubic is the crystal structure having atoms located at all the 8 corners of the unit cell and one atom at the body center. Also, octahedron is a polyhedron having 8 faces, 12 edges and 6 corners. So we need to find the location of an octahedral void in BCC structure, for which we need to draw an octahedron in a BCC crystal structure. Here we consider two body-centered atoms as corners of the octahedron, and another 4 corners of the octahedron are the 4 corners of the common face, 3, 4, 5 and 6. So let us try to draw an octahedron. So in this octahedron, the octahedral void is located at the centroid at the common face center. Also, octahedron can be drawn by considering 4 body-centered atoms, 1, 2, 3, 4 and 2 other atoms adjacent to them. Here, the octahedron is located at the center of the common edge. Considering any one of the cases, we can find that the distance between the body-centered atoms is nothing but lattice parameter A. So, from this, we can write an equation that the lattice parameter A is nothing but twice the radius of atom plus twice the radius of void. Let us consider this as equation 1. In order to find the value of void, radius of the void, we need to represent lattice parameter A in terms of radius of an atom. Let us find the relation between lattice parameter A and radius of an atom. From the hard sphere diagram, we can say that the body diagonal length is equal to 4 times the radius of an atom. So we need to find the body diagonal length in terms of lattice parameter A. On applying Pythagoras theorem, we can find that this diagonal length is root 2 times the lattice parameter A. So we need to find out this distance, for which we can consider the sides root 2 times A and A. So length of body diagonal is equal to root of A square plus 2A square, which is equal to root 3 times the lattice parameter. As we know, the length of the body diagonal is also equal to 4 times the radius of an atom. So we can conclude that the lattice parameter A is equal to 4 by root 3 times the radius of an atom. So let us write this down as equation 2. So let us substitute second equation in equation 1, that is 4 by root 3 Ra is equal to 2 times the radius of an atom plus 2 times the radius of the void. So the radius of the void is equal to 4 by root 3 times Ra minus 2 times Ra by 2. So radius of the void is equal to 2 by root 3 minus 1 times Ra, which on solving gives 0.1547 times the radius of an atom, as it is given that radius of an atom is equal to 0.124 nanometer. Substituting that in this equation, we can find the answer, which is 0.019 nanometer. This is the answer.